Hello dear students, I am here teach you step by step procedure to get good marks in external examination. So this is our syllabus, either R22 or R25 or before R16 or R17 regulation also. So now first we will discuss the fourth unit vector differentiation. Here, the vector differentiation. So first for 1 mark question here, 1 mark question here, scalar point function, vector point function. Here a scalar point function assigns a single number to every point in the space. For example, taking in our Telangana state, in different areas, different temperatures are there. Yes, so these are what? Scalar point function. Okay, it has only magnitude, does not have a direction. Then go to the vector point function. Vector point function assigns a vector to every point in the space. So like in 3 dimension, x, y and z plane, each and every point it has direction and magnitude. It has direction and magnitude. At each and every point it has direction and magnitude. It has a direction and a magnitude. Just now imagine this, you are in wind, you feel both speed and direction. Just go to the first problem. Find a unit vector normal to the surface. Let's see. Normal vector to the surface formula, del pi by modulus of del pi. Okay, or we'll write here n bar by modulus of n bar. Let pi is equals to x square plus y square plus minus z minus 10. So del pi or gradient of pi is equal to I into dou pi by dou x plus j dou pi by dou y, next plus k dou pi by dou z. Here I into dou by dou x of pi. Now pi is equal to x square plus y square minus z minus 10. Next place here j into dou by dou y of x square plus y square minus z minus 10 plus k dou by dou z of here x square plus y square minus z here minus 10. Dou by dou x apply on this x square, dou by dou x of this term, dou by dou x of this one, and again dou by dou x of this one. Next again dou by dou y of this term, dou by dou y of this one, dou by dou z of this one. Next dou by dou x of this one. So like that I am writing here I into dou by dou x of x square plus here dou by dou x of y to the power of 2 minus here dou by dou x of z minus here dou by dou x of 10. Next place j into dou by dou y of x square. Next place dou by dou y of y square minus dou by dou y of z minus here dou by dou y of 10. Next place k of dou by dou z of x square. Next place dou by dou z of y square minus here dou by dou z of z minus dou by dou z of here 10. Here partial differentiating with respect to x. So we have formula dou by dou x of here x to the power of n is equal to n into x to the power of n minus 1. So here n is equal to n equal to 2. Now substitute here vector here I of 2x to the power of here 2 minus 1. Next place dou by dou x of y square, differentiating partially with respect to x except to x, remaining all terms are constant. So this is a constant derivative 0, this is also constant derivative will be 0. Differentiating with respect to x, here x is opposite, differentiating with respect to x 10 is also constant 0. Okay, no need to write each and every term. Next place here j dou by dou y, dou by dou y of x square, there is no y term, the derivative of constant is 0. Dou by dou y of y to the power of 2, so Again, dou by dou x of x to the power of n formula, here n is equal to 2. 2 into y to the power of here 2 minus 1. Dou by dou y of here z. There is no y. Z as a constant. Derivative will be 0. Here also derivative will be 0. Dou by dou z. There is no z term. Derivative will be 0. Dou by dou z. There is no z term. Derivative also 0. Dou by dou z of here z. Z power here 1. So take here n is equal to 1. Substitute dou by dou x of x to the power of n formula. Okay. This is 0. Next place k of 0 minus 1 minus 1 into z power 1 minus 1. 1 minus 1 here it is 1. 0. Next. Here we get 2xi plus 2yj dou by dou z here, sorry, 1 z 1 z power 0 value 1. Now minus k. Need to find out unit normal vector to the surface at the point here 1 comma 1 del pi at 1 comma 1 comma 1, x value 1, y value 1, z value 1. So here 2 into x value is 1 into y plus 2 of here 1 into j, here minus k. So we get 2y plus 2j minus k. Okay, here our required unit normal vector to the surface del pi by modulus of del pi. Modulus means what? Magnitude of the vector. Del pi here 2y plus here 2j minus k divided by square root of 2 square, j coefficient 2, 2 square, coefficient of k is minus 1, minus 1 whole square. So then we get the answer here. 2y plus 2j minus k divided by square root of here 9. 3. Directly we can attach that this is a solution. So just look at the graphical representation of unit normal vector to the surface. So where we'll use exactly here. Now, so this is the here. This is a surface. Okay. So this is a normal vector to the surface. This is what here deepest distance is. Suppose for example at 1 comma 1 comma 1 we are here. Okay. ఈ పాయింట్ నుంచి మనం సర్ఫేస్కి నడుచున్నప్పుడు ఒక ఫస్ట్ తీసుకున్నాడు స్మాల్ స్లోప్ ఉంది సార్. నెక్స్ట్ రిమైనింగ్ ఇయర్ మీడియం స్లోప్. ఎక్కడైతే మ్యాక్సిమం స్లోప్ ఉంటుందో అదే నార్మల్ వెక్టర్ టు సర్ఫేస్. ఓకే, దెన్ గో టు ద నెక్స్ట్ వన్ ఇయర్ సొల్యూషన్. సేమ్ ప్రాబ్లమ్ లైక్ ఇయర్ ప్రీవియస్ ప్రాబ్లమ్ ప్రొసీజర్ హ్యావ్ టు బి ఫాలో. లెట్ ఇయర్ పై ఈజ్ ఈక్వల్ టు ఇయర్ ఎక్స్ స్క్వేర్ వై ప్లస్ ఇయర్ 2x z square minus 8. Del pi is equal to formula I into dou pi by dou x, right? So pi is what here? X square y. Next place here 2x z square minus 8. Next place j into dou by dou y of pi again. Previous problem we have written the gradient of pi formula. X square y. Next place here 2x z square minus 8. Next place here k of dou by dou z of here x square y. Next place here 2x z square minus 8. Now apply vector I of dou by dou x of this term, dou by dou x of each and every term I am writing here x square y. Next place here dou by dou x of here 2x z square minus here dou by dou x of here 8. Next place here j of dou by dou y of here x square y. Next place dou by dou y of here 2x z square minus dou by dou y of here 8. Next place k of dou by dou z, dou by dou z of here x square by. Next place dou by dou z of here 2x z square minus here dou by dou z of here 8. So just look at here, differentiating partially with respect to x, sir, except x remaining terms all are constant, so when multiply with it. Okay, y is bring out from the derivative. I'm writing here y before the differentiation dou by dou x of here x to the power of 2. Next place with respect to x 2 constant. Okay, bring out from the derivative z square also constant. Yeah, I'm writing here 2 z square dou by dou x of here x. So there is no x term, the constant. derivative will be 0. Next place here j of differentiating partially with respect to y, except to y. X remaining term is here x square. X square as a constant I'm writing before derivative dou by dou y of here y. Next place with respect to y there is no y term, derivative will be 0. With respect to y here also no term, the derivative will be 0. Next plus here k of dou by dou z, there is no z term, the constant term will be 0. Differentiating with respect to z, 2 constant and again here x is also constant, writing here 2x dou by dou z of here z square. Derivative of dou by dou z of here it is constant, derivative will be 0, right? Same here also need to apply the dou by dou x of x to the power of n formula. Here n into x to the power of n minus 1 formula. Here I of y dou by dou x of x square 2x to the power of 2 minus 1 1. Next to place 2z square dou by dou x of x value is 1. Next here into 1 into 2x plus here j into here x square dou by dou y of y value 1. Next to place here k of 2x dou by dou z of z square here 2z. Then I 2xy next place here 2z square. Next place here x square j into x square plus here k of here 4x j. Need to find out normal vector first, the del pi at the point 1 comma 0 comma 2 0 comma 2 is equal to, put here x is equal to 1, y as 0, y 0 ఉంది కాబట్టి y value 0, right? Complete term is 0, this is 0 sir. Next again 2 into z square, z value is 2, now 2 to the power of 2. Next place j of x value as a 1, 1 square. Next place here k of 4 into x value as a 1, z value is 2. So we get 4 to the 8, 8i. Next plus j plus here 8k. So our target to find out unit normal vector of the surface del pi by modulus of del pi. So this one is equal to del pi 8i plus j plus here 8k divided by square root of coefficient of I here 8 square plus here 1 square. Next place here 8 into k. So here 8 square 64 64 128 plus 1 129. 8i plus j plus 8k divided by 121. So this is the our required the normal vector of the surface. Next one, angle between the normals to the surfaces. Here to find out the angles we have two type of questions are there. Okay, two type of questions are there. So the first type is here one surface, 2 points are given, right? So let here pi is equals to given function here 2 surface 2x square, next plus here 3y square minus 5z. Okay, here find out the del pi. Because angle between normal to the surfaces, normal vector to the surfaces cos theta is equal to del pi 1 dot del pi 2 divides modulus of del pi 1 and the modulus of del pi 2. Or so we can write here n1 bar dot here n2 bar divided by modulus of n1 bar dot modulus of n2 bar. So here we have only one surface. I'm going to find out here del pi. We know very well about the del pi formula. I dou pi by dou x plus j dou pi by dou y. Next place here k into dou pi by dou z. Now we are I into dou by dou x of pi. Pi is equal to 2x square plus here 3y square minus here 5z. Next place j into dou by dou y of here 2x square plus 3y square minus here 5z. Next plus k into dou by dou z of 2x square plus 3y square minus 5z. Same apply here. I into dou by dou x of here x square, dou by dou x of 2x square. Now apply dou by dou x of entire term. ఇందులో x term ఉందా? లేదు. So constant కాబట్టి 0. I'm writing directly dou by dou x of this term. ఇందులో x term ఉందా? లేదు. So 0. Next place here j of dou by dou y of this term. ఇందులో y term ఉందా sir? లేదు. So dou by dou y of Next term here 3y square, dear students. Next again dou by dou y of here minus 5z. There is no y term, the constant is 0. I'm not writing 0 again. Place here k of dou by dou z. There is no z term, the constant 0. ఈ term 0 అయిపోతుంది. Dou by dou y z of this term, z లేదా term లో. So constant కాబట్టి 0 అయిపోతుంది. Remaining ఏముంది సార్? Dou by dou z of here minus 5z. Right. Now here differentiating partially with respect to x. So here 2 as a constant, bring out from the derivative. I of here 2 dou by dou x of here x to the power of 2. Next place 3 as a constant, j differentiating with respect to y. So here 3 constant term. So writing here dou by dou y of y to the power of 2. Next again plus into minus, minus 5 is a constant. So bring out k dou by dou z of here z. So here 2 dou by dou x of x square, again here 2x into y. Next place 3j dou by dou y of y square, value here 2y. Next minus 5 dou by dou z of z value is 1, k into here 1, 4xi. Next plus 6yj minus 5k. Okay, so normal vector to the surfaces means normal vector to the surface at first point. Here 2 comma minus 2 comma 4 is equals to, put x value, y value and z value. X equal to here 4, x value here 2 into I. Next place here 6, y value as minus 2, j minus here 5 into k. So 8i minus here 12j minus 5k. Normal vector to surface del pi 1 or here n1 bar. Okay, next again normal vector to the surface at the point minus 1 comma minus 1 comma minus 1. So x value minus 1, y value minus 1, z value 4 of here minus 1 into I. Next plus here 6 of minus 1, sorry, 6 of minus 1 into I. Minus 6 into j minus 5k. Here minus 4i plus here 6j minus 5 into k. So writing the cos theta. Cos theta is equal to here del pi 1. Del pi 1 here 8i. Next minus here